We're now going to practice taking derivatives using the chain rule. So the first function we want to take the derivative of is h of x equals 3x squared plus 5x plus 2, all of that cubed. So our outer function here is x cubed. So remember the chain rule says we're going to take the derivative of the outer function, which here would be 3x squared, and we're going to compose with it the inner function, which our inner function is 3x squared plus 5x plus 2. So the first step is we're going to compose our derivative of our outer function, 3x squared, with our inner function. Okay, now our inner function is 3x squared plus 5x plus 2, and our last step is to multiply by the derivative of the inner function, which is 6x plus 5. So our last step is we're going to multiply by 6x plus 5. So that's our derivative of our function. And notice, you had treated the inside function kind of like x. What we did is we brought the 3 down, left that alone, lowered the power, just like we would in the power rule. And then since this wasn't just x, since it was something inside, we had to multiply by the derivative of it. Okay, next we're going to look at h of x equals e raised to the 3x plus 7. So our outer function here, f of x, is e to the x, which remember the derivative of that is easy, it's just e to the x. So taking the derivative of our outer function and composing it with our inner function, which is 3x plus 7, is just going to give us e to the 3x plus 7. So now we need to multiply by the derivative of g prime of x, which is just 3. So whenever you have e raised to something, you're going to have e raised to that thing. Okay, it's going to stay the same, but then you need to multiply by the derivative of that stuff that you raised it to. Okay, so just another quick example. Let's say you had e raised to sine of x. We'll call that h of x. Well then, if you want h prime of x, you're still going to have e raised to the sine of x, but then you multiply by the derivative of sine of x, which would be cosine of x. Okay, so that kind of rule will always work when you have e raised to something. Okay, now we have tangent of x composed with e to the x squared. And this is a little different than what we've seen because what we're composing with now is not just a simple function, we're going to have to use the product rule. Now, I always tell students when you're trying to find derivatives, work from the outside in, okay? So you want to kind of look at the outer concept, which is the chain rule, and we're going to start with the chain rule. So our outer function is tangent, and the derivative of tangent is secant squared. So we're going to have secant squared composed with e to the x squared. Well, now we need to multiply by the derivative of our inside function of e to the x squared. So we need to find the derivative of that, and to do that we use the product rule. So it's going to be e to the x times 2x plus, now we'll take the derivative of e to the x, which is just e to the x squared. And if we want to simplify this a little bit, we could write this as e to the x times x squared plus 2x if we pull out the e to the x and then write it in descending terms. So this would be secant squared of e to the x squared times e to the x times x squared plus 2x.